The way it is showing 6%, like, yeah, click on that. Thank you,
Okay.
sir.
I
So
think
click on the hide. So at the bottom, a pop-up window is coming.
I think
Message is coming. Sir, no, no, no. Where it is written Pradeep Kumar, Principal Scientist, you will see there's a message written. Sir, on PowerPoint. On PowerPoint.
on PowerPoint.
Yes, sir.
Okay, right.
Click on hide. Okay, sir. Minimize the screen. So
Okay.
everything is fine at your end. The time
Yeah.
allotted is 1 hour. We will
Okay.
keep 5-10 minutes at the end for question and answer session. We have turned the microphones of participants on mute so that there will be no distraction during the lecture.
Okay.
Once the lecture is ended, they can ask the questions.
Okay.
Good afternoon and welcome all. It's a great pleasure to welcome Dr. Pradeep Kumar, Principal Scientist, Division of Vegetable Science, ICAR, New Delhi, to today's online session. Dr. Kumar joined the Agriculture Research Service in 2008. He completed his BSc Agriculture from Ayodhya, MSc Horticulture from BHU Varanasi, and earned his PhD in Horticulture from the University of Brescia, Italy, with specialization in soilless cultivation and vegetable grafting for greenhouse production. He has published more than 100 research papers with over 3,000 citation and has led several national and international research projects. Dr. Kumar is widely recognized for his valuable contribution to protected cultivation and vegetable grafting technologies, supporting farmers and entrepreneurs through his research and extension activities. We warmly welcome you, sir, and look forward to your valuable insights in today's session. Please continue.
Thank you. Thank you very much. First of all, thanks for giving me this opportunity. Although I cannot see the participants at this moment, probably I'll be able to see or interact at the end of the session. So I go straight away with my presentation. I'll be sharing some of the my key works what we are doing here and some of the basic background of protected cultivation. Although this is a training on protected cultivation only, so you will be getting a lot of knowledge and insights related to this particular subject. So what aspect I have been dealing with here, and some of the experiences I have learned elsewhere, I will be sharing on those aspects too. So my topic is innovation in protected cultivation. Actually, I thought I could put some more information from different presentations I have been doing. But meanwhile, since morning I was busy somewhere, so I could not incorporate all those information. But anyway, I will try to cover all those things also. So I'm not going into detail what is protected cultivation. You all know what is the two basic purpose of protected cultivation is protect crop from external factors. This could be anything like which crop does experience outside in the field, whether it's a hailstorm, high radiation, like in the arid region, high temperature, low temperature, and so on. So, and the next, and the second one is to create favorable environments. Where you have some covering, any type of covering, and that certainly is going to create some kind of a modified environment. So the two objectives that is actually achieved with the protected cultivation. So it is actually the growing crops under protected environment. Any sort of environment, a protected environment, we provide to crops that comes under protected cultivation. So I just give it by definition. I'm not going because sometimes many of the students they get confused. What is protected cultivation? What is greenhouse cultivation? So here just I want to flag this. So where both permanent and temporary structures are covered under protected cultivation, whereas in greenhouse cultivation, because globally term greenhouse cultivation is was accepted, but since India started, India came into picture at global level in protected cultivation. Then only we started using words polyhouse and the net house. Earlier, otherwise nobody was accepting at the global level. One of my papers, I got a comment from the reviewer when I wrote a Polyhouse in 2015-16. So they asked, what is Polyhouse? Define it. So it was then defined a plastic greenhouse. Then Polyhouse is in the bracket plastic greenhouse. So now it is being accepted elsewhere also, but the little means greenhouse cultivation does include only permanent structure, whether it's a glass house, net house, plastic greenhouse, polyhouse, or anything else permanent in nature. Whereas in case of protected cultivation, it includes both permanent as well as temporary structure. That is why when you see area under protected cultivation, it comes in like a 1.1 few, like a 3 lakhs to 1.2 lakhs in India. But actually, the greenhouse cultivation area is around 60,000, 70,000. It's not even, means it's less than 1 lakh hectare in India. So I'm not going into detail what is the advantage, you all know, and people have been, but I consider the greenhouse cultivation or protected cultivation is one solution for multiple that deals with multiple issues or problems. So it is one solution for where low productivity, for example, in difficult areas, water and nutrient use efficiency, if we are intended to enhance the efficiency of water nutrient, and a harsh hostile climatic condition, whether it's a Leh Ladakh region, cold desert, or a hot desert of Rajasthan, and unemployment opportunity. And this is one area that is attracting youths and retaining youths in agriculture. Globally, if we go for the status of protected cultivation, this India, if you see this India is at earlier it was at 38th place around 10 years ago, 2020. Hitman's data was there, 38th position. But now globally, India has a position of like a China, followed by Spain, Italy, then India. Means we are at 4th position globally. Even our area is around 110 and 115, like 1.1 lakh hectare or 110,000 hectare. This is a global data presented by Professor Guda. He is a well-known scientist across from Germany, who has a lot of work on protected cultivation. He presented this data in last year only in Athens. So this is the trend how the global protected cultivation industry is growing. Worldwide, if you see, this was the situation of China. Weifang Prefecture, which is located in Shandong province in northern China, where 82,000, more than 82,000 hectare area means under protected cultivation, and especially greenhouse cultivation. And whereas the total area under protected cultivation is 19 lakh hectare in 2024 in China. And this was the situation during May 1987, and this is the May 20 by 24, and this was from the this was actually released by NASA and their website only. So, and before that, Algeria was leading place for protected cultivation. The most concentrated polyhouses or protected structures were in southern part of Spain, that is Almeria, and around 70% of the geographical area was covered with this, and around 40,000 hectare greenhouses were there. But in China now it is double than like 82,000 hectare in a single province, that is a Shandong province. Whereas in Granada, that is Almeria, in Granada province, Almeria, there was around 42,000, and surprising, the rainfall of that particular area is only 200 millimeter per year, and the water desalinization is the main means they have a desalinization by which they are irrigating their crops. Although 200 mm rainfall falling on the surface of the plastic, they are collecting them and they are using. So almost around 30 to 40% water for irrigation is met by the desalination of seawater. And soil is also not there, and they are using artificial soil, using 3 different soil, mixing clay, manures, and sand. I have visited there. It's a it's all rocky areas. They are having all the soils are artificial, and they are making the layer of clay manure and sand on the top, and they don't use mulching because it's a pure sand, and there's the sands are used as a mulching. Unless it is a very high-tech greenhouse cultivation, most of the moderate greenhouse cultivation in this particular province. And now in India, if you see, protected cultivation has taken shape and moved from cold desert to hot desert. And in 1970s, when the first greenhouse was built, was in 1974-75 by the Bihar DRDO in cold areas, and it was thought that the greenhouses are only useful under cold climatic condition, and then then in some other states like Jammu and Kashmir and Uttarakhand, and very late it came down to the plains. And when Indo-Israel project at IRI, where you are taking training, and they started working on that with the help of Israel, and developed a CPCD and came into picture. And since then, there was some progress, but the main progress, or you can boom, came in 2010-11, when actually it spread like a fire in particularly in Rajasthan. And now you see this scenario, changing scenario from cold desert to hot desert, and now it's it is the picture you see there. The next picture, you see this one is the mini Israel. It is called mini Israel. You can see some of the picture, somewhat looking like what we see in China and Algeria in Spain, and Shandong in China. So this picture is growing day by day. So again, you see here, you can see all the greenhouses. There are polyhouses, and there are 3-4 polyhouses surroundings and one pond, water body. So every drop falling on the greenhouses are being collected in the pond, and they are being utilized, because there is a issue of groundwater. If somebody is from this particular area, Rajasthan, they understand the scenario. There is a like a 500, 600 and beyond feet groundwater, and that is also not of good quality. So they are using rainwater and mixing with the groundwater, so they are able to grow 2 crops cycle in a year. So the main crop cycle of this particular region is starting from July and ending by 15th May or end of the May. So they are taking 2 crops, and mostly they are taking cucumber, planting in last week of June or first week of July. Then one crop is running up to when the end of the October, and then another crop from October, November to sometimes in first week of May or middle of May, depending on the temperature rise and the crop planting. So, and there are some big success stories are also coming out from this desertic state. Like two IIT and IIT Mumbai graduates, they started, they came into this with the Iki foods. So they are running at this moment 110 acres of greenhouses in different districts, and they started from Kota, and this is their patented hydroponic structure, where they have designed their this structure. In this they are growing, and also they are using some cocoa peat and the soil also. So, and there are some entrepreneurs, they developed from Kajri itself, and we have a agri business incubation center. This is a small picture. There are so many farmers, entrepreneurs, they are coming, like this one. They say now Neil Chaudhary is nearby Jodhpur only, and running 20 acres of greenhouse. Here 11 acre. This is of last year pictures, and now he is running 20 acres of greenhouse. Likewise, and there are so many young entrepreneurs. All are young and less than 45 years. So they are running beautifully a greenhouse structure, and mostly they are using net houses. And net houses are better in our condition than the other area, because there are very less rainfall, and then and the high temperature. And that's why the polyhouses, there is some problem when, particularly during summer. But in net houses, the summer crops can be taken in better way as compared to the polyhouses. And so way to increase sustainability, because the growing area under protected cultivation is increasing day by day, particularly in western Rajasthan. I think I did not put that slide. I could show you one survey done by Holland Door company from Netherlands in 2020. They released one report on protected cultivation, and they presented a area-wise, structure-wise, and the growth year-wise. So in that map, they have shown that around 42% of the total greenhouse cultivation area is concentrated in western part of the country. In that, Gujarat, Rajasthan, and part of Maharashtra is covered. So 42% of the greenhouses across the country come from the three states only. And among three, the fastest growth is in Rajasthan only. So the area and production is increasing. So how sustainability can be achieved? So we have to support farmers. Being a agriculture scientist, so we have to support, because it's a very huge industry and a lot of investment is involved. So from developing good varieties to the microclimate management, then growing practices, then fertigation, everything we have to fine tune according to the situation, because we cannot copy and paste the technology coming from European countries or America, or even within the country from one part to other. We cannot simply copy and paste. We cannot use same technique. So we have modified many of the practices that is now relevant for our region. For example, irrigation. Earlier it was an alternate day. Now it's a every day, and now we have found that for pulse irrigation, like in the soilless culture, three times a day, that will be more beneficial. And likewise, fertigation, everyday fertigation, even 3 times a day fertigation we are giving, and some of the farmers they are giving. So we have reached to that level to optimize the water and nutrient use efficiency in order to avoid the leaching. And then we are going for pulse irrigation and fertigation. So different means more frequency, and not only across the week but also within a day. And now flat roof net house, it's the game changer, particularly in our western part of Rajasthan, because it's a very low cost, only 12 to 30 lakhs per acre, even without subsidy. 90% protected structure in our region is coming with a self-investment without taking any subsidies. Farmers are young entrepreneurs, they are coming and they are investing. And believe me, within 3 crops, they are means ROI is only three, within 3 crops they are getting all the investment back. So like from each crop they are around 4 to 5 lakhs in net profit is coming, and 3 crops is around 14 to 15 lakhs net profit. So in 3 crops the whole investment is coming back. And then solar energy plus roof rainwater harvesting greenhouses. This is also wherever polyhouses are there, then solar and the water bodies, water harvesting pond is essential. And these are coming wherever polyhouses are there. Now they are integrating with this, and this is giving a good return in terms of saving energy and having good quality water that is being used in the irrigation. And one success story from here, our farmers, he runs 1,000 square meter polyhouse, and he does not have any tube well, only water collecting from the surrounding his own field, and the water coming from the roof of the polyhouse. So the same water is 60 lakh capacity pond he has, and this is good, and the water collected from here is good enough to have 2 crops successfully in this protected structure. And this is our intervention, where we are recommending, we have already standardized technology, and 4 mm and 2 mm thermocol ball, and spreading on the surface of the water body. And this is checking up to 60 to 70% of evaporative losses is checked by the use of this particular thermocol ball. And not only using for this with the use of groundwater, but also we have done some study where we are using water falling on the roof and taking in the pond and conserving reducing evaporative losses, and we are using the same water for our hydroponic system uh, very efficiently, where we are able to reduce water requirement from 300 liters to 18 liter per kg of tomato production. This is our own greenhouse, and the production where we could uh, brought down the water. This is a virtual water requirement for producing 1 kilogram of tomato. That is always reported around 300 to 400 liters of water to produce 1 kilogram of tomato, and that we are normally only using simple greenhouses. It is around 40 liters, 35 to 40 liters, and when using recirculating system, closed loop system, then again the water footprint is reduced to 18 liters per kg of tomato. So in this case, roof rainwater harvesting is done, and the thermocol ball to check the evaporative losses and conjunctive water. If it is soil-based cultivation, then using rainwater and groundwater. Otherwise, in this case, only rainwater, and we not to use RO water, because it always in hydroponic RO water is recommended. But if you don't have RO, and then the rainwater can be used. And when we put thermocols on the surface, then there is also not a problem with algae. So that water is only filtered and then used in hydroponic system. And we also have one design where low structure 1.5 lakh rupee mein 1.5 lakh rupees structure 2-layer net house of 18 into 8 meter. And then we have standardized this practice when like in September to April, one crop is taken, whether it is a tomato, pepper, and cherry tomato. And then in May, soil solation is done. In June, July, seedling production is done for open field cultivation during like a chili, tomato, and several other crops are planted in June or July. So for them, farmers, they struggle to have a good quality seedling. So if someone follows this practice, then there is a ROI within 1.5 year, and this supports a farmers family, small farmers family, like providing 12 to 13,000 rupees per month by investing only 1 to 2 hours a day having these crops. And if plants in the crops are sold locally. So this is all that low tunnel, low cover. This is boon for some of the desert area, like starting from Bikaner, Hanumangarh, and then Ganganagar, thousands of hectare area under low tunnel or low cover technology, and they are earning too much, because normally the cucurbits are flooded in May, June. But in this case, using this is a small intervention, the harvesting is advanced by 30 to 45 days. So the return is increased by 100 to 150%, almost double. And this is one example somebody may show you, but I also want to highlight. 8 acres vegetable nursery is run by a Kurukshetra entrepreneur, Harbir Singh. He is simply selling chili seedlings, and they're having 3 to 4 seedling cycle in open field and 8 acres. And you can see earning in crores. Then reflective mineral mulch, because plastic mulch, of course, it conserves. It's an essential part of water saving practice in precision agriculture. We have found that feldspar cheaply available in Rajasthan. That is a potassium-based feldspar, and it has a very good. It has shown in our study a very good water conservation, as well as improving hydrothermal properties. That is why microbial population is also increasing and providing a result similar to the plastic mulch. And moreover, when farmers use plastic mulch during summer, then there is a problem: early establishment, because of high temperature and poor lanky growth, and sometimes there is a root burning is also there. Mulching in greenhouses in high temperature area are used in 2 seasons only, One is a rainy season and another one in winter season. But in summer season, they avoid. But this mulch can be used around the year with a multiple benefit. So we have also used in open field in case of onion, because onion is grown during summer, like planting in January and the last in made up by end of April or May. There is no rain, because the problem with this application of mulches is the water splash, whether it's a sprinkler irrigation or rainfall. But in under drip, any summer season crop can be taken, and this reflective mulch can be used. Then retractable roof greenhouses, because greenhouses, when plastic house like a polyhouse or net house are used, then there is a some issues, because either it's permanently covered or permanently open if it's open cultivation. But retractable greenhouses, they are as per the climatic environment requirement, and then can be managed by the partial shading. There is a shading as with the use of sensor as per the crop requirement, can be fine-tuned and regulated with the help of sensors. So this is one, but this is very costly system because it's permanent in nature. The plastics it runs of course for 10 years, but the installation cost is very high, because the high structure and the plastic is very costly, because this is very rigid and it can sustain even in cyclone up to 150 160 kilometer per hour. So but it's always you see in India 3 to 4 places where the farm size is more than 15 acres, then only it's like usable or beneficial. Otherwise the cost of installation is very high. Then another one, semi-transparent photovoltaic greenhouse film is coming up. This is not our research, but we are going to install very soon this kind of a system, where we'll be having the photovoltaic cells on the greenhouse. In one project we are going to install. So this can be a very good technique, I believe, because in our area there's abundant solar radiation is there. We always be only 2 months from 15 December to 15 February we require shading and not shading. Otherwise we require a 50%, more than 50% shading. So we have a very high light intensity, like sometimes 1.5 lakh lux during peak summer, and whereas requirement for this most of the greenhouse crops is less than 60,000 lux. So always it is higher than 1.2 lakhs. Like today if we measure, it is 1.1 lakh, so more than 1 lakh lux. So we need to provide a shade up to 50%, and sometimes more than 50% during peak summer. So this is a good one fortune that we can utilize and harness the potential of the solar available here. So this is 110 acres farm at near Hyderabad, Siddipet. So where Simply Fresh, they have installed this this kind of structure, and they are able to grow around the year even leafy vegetable that requires less than 25 degrees Celsius temperature. But I visited there, that outside temperature was 42 degrees Celsius in April, but it's inside temperature they could able to maintain 26 degrees Celsius by using a fogger and the top, and the top was open. One layer of shade was covered, but not the plastic. So in this way they are able to manage the but if it is a plastic greenhouse, then of course the radiation is coming, that is increasing the temperature because of the greenhouse effect. But when it is only shade and having not a vine crop and fogger, good quality fogger, then you can create because by evaporative cooling, good environment. So optimal root zone environment is very essential, whether it's by automation or by manual, using small equipment running means only to achieve a pulse irrigation. If we provide a more frequent irrigation using any kind of tools by which we can, like a relay timer, or if it is a automation large farm, then automation does well, because it can precisely apply water and nutrient as per the requirement we can set. And like for example, for tomato, you cannot fertigate throughout the crop season similarly, because every stage they have their own, their requirement is different, and even nutrient requirement is also sometimes different at different stages. For example, the at germination to establishment some micronutrients are required, but some others like a carbon, boron, particularly boron and calcium, sorry, boron in case of micronutrient, and calcium in case some major nutrient is required when fruit set is more. So this can be applied only with some kind of good fertigation system, and particularly if it is automation. Otherwise it can also be done easily done by the eventually manually. So this is just to show that the how we can achieve more yield by providing a better root zone environment, whether it's with regard to the water requirement or fertilizers requirement. And the most important thing is to maintain optimal pH level in the root zone to achieve higher growth and yield. Today, earlier we do not have such fertilizers, but today we can see in the market low pH specialty fertilizers are also available. Whether it's a phosphonographic cucumber and capsicum, or but also you have to understand the growth pattern and the soil characteristics, water quality, and then how best we can utilize all the resources to have a better production and yield. So in this case, the low pH specialty fertilizer, although they are costly, but farmers they are using. If I give one example, like if you use very crude fertigation schedule, for 1 acre, 25 to 30,000 rupees fertilizers is needed. But when you go to really use very good quality fertilizers and with good result, and that costs around 60,000 rupees per crop per acre. So farmers are now realizing the benefit of using good quality fertilizer, low pH fertilizer, because particularly in our area where soil pH is also high, water pH is also high. Soil pH is around 7.88 and water pH is also around 8. So in this case, like a slightly alkaline water there. So we found that when we reduce or we apply acid, simply acid, when you with the application of some acids, you reduce the pH and bring down to like a 6 and 6.5 or around 6.5, then there is a better nutrient absorption, also better growth and yield. So that could be achieved with the use of the low pH fertilizer, because fertilizer are means the nutrients are getting taken up by the plants very optimally when the optimum root zone condition is provided. Water is available there, fertilizer is of course available there, but if they are available in the available form, means at the narrow range of the pH, because some of the fertilizer they are not available when the pH go beyond 7.5. Likewise, when below 6, some other elements they are not able to be taken up by the plants. So when we have optimal pH in the root zone and optimum moisture, then of course the nutrient absorption and the water absorption and the resulting to the better growth of the plants. Although I have some more slides, but I could not watch here, but I want to bring you to soilless cultivation, what we are doing here. You know, soilless cultivation advantage, this excludes the soil related issues, whether it's a soil-borne diseases, and more importantly, this soil anomalies arises by growing crops over the years. So there is a lot of variation in the nutrient availability. After 2 to 3 years, there is a very like a fixing of a phosphoric fertilizer. We observed that phosphorus availability in our soil is a normal range in 15 to 18 kg per hectare. But after 2 years, this phosphorus level in the farmer's fields goes beyond 100 kg per hectare. Like so much phosphorus is being fixed in the soil. So we have to explore them. So likewise, so many issues are arising, like micronutrient deficiency is coming, and inherent micronutrient deficiency are coming, and some excess nutrients nutrient elemental means if there is increasing level of some of the nutrients. So this is creating imbalances. So the target yield could not be achieved unless you provide a balanced nutrition. So every time it is impossible for the farmers to go for a testing at a regular interval. Based on this testing, they apply fertilizer, and they are not able to even make their own fertigation schedule and fine tune. At a very few farmers they are able to do that, and they are achieving higher yield. But I'm not saying that soilless cultivation is like essential, but soil, if you really want to control everything, then soilless cultivation is one area which already Europe they have realized, and then controlled production is possible in soilless cultivation. But in urban area, peri-urban area, where demand of leafy vegetables and exotic vegetables increasing, of course, there is this area is going to be a game changer. Soilless cultivation, if you see the market at global level, the CAGR is 11.3% at globally. But if Indian CAGR is more than 16%, that means growth in India is very high because this is a new emerging area. This also increases resource use efficiency. That is actually this European Union has realized it, and in their target 2030 target, they intend to reduce nutrient losses by 50%, reduce the fertilizer use by 20%, and they have a target like in that is Green Deal 2030. They have some of the objectives in Green Deal 2030. That is a Euro farm to fork, and that is one area is a fertilizer and pesticide, another area is a water saving. So in that way, they are going to reduce fertilizer wastage and pesticide wastage use by 50%, and by reducing the wastage and increasing their use efficiency. So high water use efficiency, that we have calculated that normally 300 liters of water is required to produce 1 kilogram tomato in open field. But from the same quantity of water, we could get a 20 kilogram. We could produce 20 kilogram of tomato in the greenhouse. This is our greenhouse, how we are doing it. This is the aeroponic system. You have heard about the aeroponic. Aeroponic is not only for the potato tuberlets, but also this can be utilized for growing vine crops and even leafy vegetables. So in this case, you see we have beautiful tomatoes are growing in. This is your aeroponic system, and this one is a hydroponic Dutch bucket system. So in both cases, the production level you can see. Here you can control all the production growth and everything, because you provide all the essential elements from outside, and we can control growth, everything. You can see very nice crop and very high level of production we could achieve, and the quality also. How protected cultivation is going to be a boom and means in the future. If you take example of tomato, the productivity of tomato in India is around 25 tons per hectare, whereas there are 12 countries which is having more than 10 times high productivity than our productivity. It's a national productivity. It is in Netherlands. They have a productivity 509 metric tons per hectare, because all the tomatoes they are growing, all tomato, 100% tomatoes are grown inside greenhouse. Not a single plant is planted outside, except they are small. Even they have in kitchen garden they have a small greenhouses. So commercially, all the tomatoes are coming from the greenhouses, whether it's Netherlands, Norway, Sweden, Belgium. So and you can only find in the southern part of Mediterranean regions of Europe, where tomatoes are being grown outside, and mostly the tomatoes grown outside are processing tomato. They are growing processing tomato outside and table tomato inside the greenhouses. That is why their productivity level is very, very high. So it gives indication that if we can also achieve this level if we can control all the microclimate, nutrition, and everything. So even recently in one report, a Dutch greenhouse that yielded around more than 700 tons per hectare. using all the modern tools and techniques, especially in resources. If you see the recirculating water vapor, they are dehumidifying and collecting water, and then this water whose efficiency is very high, nutrient, they are providing a nutrient, and the recirculating system where nutrients are corrected, the changes in nutrient composition they are correcting automatically, and CO2 level they are using 800 to 1000 ppm consistently, because they have a low temperature zone, because the temperature is not very high. That's why they are using CO2. But we do not use CO2 to increase photosynthetic efficiency. Only we need to improve, or we need to optimize the microclimatic condition. We could achieve a high level of yield. Then hydroponic and aeroponic can be used for very easily. That can be used and being used for biofortification. For example, this slide shows the selenium and iodine biofortification. It is possible by fortifying the nutrient solution. If we fortify the nutrient solution, we can put selenium at means predefined level, because we know the toxicity level, and that is why we need to do research at what concentration we need to apply, so that in the foliage part also this is not beyond the limit that is not useful, or even rather harmful for the human being. So that can be fine-tuned and can be optimized by doing research. And one of the researches are we found that a different growing system can modulate the uptake pattern and of nutrient and water. And you can see the left side, this is simply the cauliflower. This is an NFT system, and this is the aeroponic system. Hydroponic and aeroponic, you see the growth of the roots, and also some of the parameters, quality parameters, like a zinc. If we talk of a zinc fortification, if you see the curd, aeroponic curd is having 73 milligram per kg, whereas this NFT system is a 54. So around 25 to 30% more zinc content is simply by using this technique. And likewise for iron content also increased from 100 to 123 likewise. So it is all, and also ascorbic acid and total antioxidant. So everything means like quality parameters also also be analyzed in nitrate content that was under the limit, because nitrate concentration is a concern apart from the biological, like E. coli and other things, in case of a hydroponic system. So that was also under the threshold limit, nitrate content, because the roots are bigger in this case and they absorb more water and nutrient, also nitrogen. Nitrate content was higher, but what within the limit, so there was no any harmful effect is expected by eating the produce from growing from the aeroponic system. So vertical farming, this is like a vertical, we have a tower system, and then this just to show you other systems of vertical farming. And these are some successful entrepreneur startups in our country, like Urban Kisan, Future Farm, 365D, and there are so many. At today, around 2,000 such farms are there in India. There is one group, they used to compile all the hydroponic growers list, and around 2,000 growers are there in India. They are sorry, 200, more than 200, not 2,000, more than 200 farms are there. Means the farms are at least about at commercial scale are there, that they are successfully running hydroponic system or vertical farming. So artificial lighting, when we talk of somebody may take some lecture, but just here I have one slide. Artificial lighting play an important role in case of indoor farming, whether it's a plant factory like multiple state farming, like this one, or this one at indoor, wherever indoor farming is done, then there is some requirement of because we exclude light, the solar or sunlight, so we have to provide the artificial light. And artificial light, there are a lot of studies going on, particularly if you see, if you want to have this kind of green leaf lettuce, so so the combination would be like a red light, blue light, and green light, and then you reduce increase the blue light, and you'll have the purple color lettuce. This is just light composition is affecting the quality of the produce, and this is in general given the DLI for the different daily light integral, and mole per meter square per day is requirement. If it is microgreen, very less light. But if it is a crop like tomato and capsicum, then 35 DLI. And the lettuce, it is around 17, 15 to 18. Then basil, 12 to 15. So every crop, you cannot have a same light for everything. Maybe you have same light, but the light quantum of light required for each crop is different. Particularly green, leafy vegetables require more, and the when you want to fruit, the fruit, of course, they require more DLI. So this is plant factory where the artificial lighting is needed, but it is not essential in some of our regions. If we have a light available abundantly like this one, so maybe by using the natural light we can grow crops vertically. And these are the examples where natural light only, based on natural light only, this vertical farming can be taken up. Then container farming, of course, is coming where space is less, or barren land, or in the city you have a means unconstructed area or roadside, anywhere this kind of farm can be created. Of course, these are the costly affair, but it's a future. And some of the countries, they are already having this. Even in Mumbai, I've seen some company, they have this. So this is coming up in the future. In the next few years, we'll see a lot of containers, roadside container or area where they can rent the container, and there could be even hundreds of containers, and they can rent out, and somebody is going having key, and they are running one container, two container, few containers. So this is a coming area for entrepreneurs also. So now another topic is a grafting, vegetable grafting for dealing biotic and biotic stresses. So this is one area where I'm working. Apart from our soil-based cultivation and soilless cultivation, this one also, we all know, we are horticulturists, of why grafting is important in vegetable. It's a relatively new area, but this has a good opportunity, especially when there is a issue of soil-borne diseases, salinity, drought stress, and also even some recent papers they come up for foliar disease also. So quickly I will go. Although there is a difficulty to transfer one gene from relative species to another, whereas the grafting can be an intra or inter interspecific or intergeneric. Like a cucumber has shown good compatibility with the loofah legionnaria, whereas we cannot cross cucumber with the loofah legionnaria. But the legionnaria roots can be the potential of legionnaria or loofah or cucurbita roots, the potential can be harnessed by grafting in cucumber. So likewise in muskmelon, that can be grafted easily on backsword, cucurbita, loofah. Watermelon also, wild watermelon, bottle gourd, squash, and tomato brinjal also wild, and several wild and the related species that could be grafted. The grafting actually it began in late 1920s when the Japanese farmer he he grafted watermelon on pumpkin root stock and found the plants which were grafted, they had a resistant to the particular disease. The plants were not died, but the other plants they could die because they were susceptible to that. And this is because of host specific resistance. The pathogen that affect the watermelon, the fusarium wilt that affect the watermelon does not affect the pumpkin. The pumpkin is resistant to particular those arids. So this is host specific resistance can be incorporated. So the major breakthrough in grafting came after the banning of methyl bromide, because unless methyl bromide till the methyl bromide used was in practice, particularly in Western countries, they were not uh, 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 they, they were using it like anything, especially for successive cropping, like some vegetable cropping, and strawberry, especially in strawberry in California. And there, thousands of hectares they used to treat soil with the methyl bromide. So, but because of its environmental concern and human concerns, it started phasing out from 1995 to 2005. It was completely banned in 2005 for agricultural uses. Then the researchers, they realized the potential of grafting, and then they started doing it. If you see the literature, 1995 onward, research on grafting increases, and today every almost 100 countries they are using grafting either in research at research level or at farm level. So presently, it is not only 30 countries, around 100 countries now. They are using it in at a small to larger scale, and mostly concentrated to the Japan, Korea, and China is the leading one. They also lead in this. And 100% watermelon in Japan, Korea, Spain, Italy, Turkey, and Cyprus are grafted only. You cannot see in Mediterranean region of Europe. I've seen in Europe, Cyprus, in Tunisia, in Israel, and in Spain, Morocco, everywhere, the particularly watermelon, and 100% watermelon, they are grafted only, even in Japan, Korea too. And almost 90% greenhouse cucumber in Japan and Korea, they are grafted. And almost 100% tomato plants in Netherlands, Sweden, Germany, they are grafted only. Well, although they use soilless cultivation, they do in rock wool or cocoa slabs, whatever media they are using, but they are essentially using grafted plants. Why? Because their main motive using grafted plants on bigger root stock is to enhance the growing cycle, enhance the production, enhance the bigger, because they use 2 to 3 stems, usually 2 stems per plant, and for having 2 stems, having more yield and growing cycle, large growing cycle, and it is essential the root system should have better capacity or capability for water and nutrient uptake. So in general, plant doesn't have that capability. It cannot last like 11 months. That what they do take. They run their crop cycle up to 11 months, just 1 month for cleaning and all. Otherwise, they are having year-round cultivation. And normal plants could not sustain beyond 9 months, but grafted plants using some bigger root stock like Maxi 4, and they take up they grow tomato up to 1 year. So this is the how grafting industry is growing. Although this is the older data, but you can see the trend how it is increasing. China is the leading country in the use of grafted seedling vegetable crops, followed by Japan, Korea, Spain, Italy. India is also emerging market, and in like Chhattisgarh, Jharkhand, then Gujarat, and then and also one of my entrepreneur at Bagpat in near Delhi, and one in Himmatnagar and the Kalol. There's so many. They are selling in lakhs and lakhs seedlings. Baramati KVG itself, they are also selling. So many, even in Maharashtra, many farms they have come up with a grafted seedling production in Gujarat, and mostly started from Raipur, Chhattisgarh, Vienna. They are the pioneer in terms of commercialization of this grafted seedlings, and now so many nurseries are coming up supplying grafted seedlings of different vegetables. So we know some of the advantage and disadvantage. The disadvantage: high cost, skilled labor, and low availability. Because grafted seedlings, you can particularly have cucurbit crops, it cannot be transported a lot to far area because because of their delicacy. Whereas in tomato, capsicum, and the brinjal, that can be transported thousands kilometers in 2 to 3 days if they are in boxes. No damages happen. But in case of cucurbits, they are very delicate and it's very difficult to transport them to large far area. So it is essential to have availability at a local level. That is one area that is picking up now, but still there is a lot of scope in this. Skilled labor that can be trained with a very small effort, and high cost. Yeah, of course, high cost, but production is very high. These are the crops. Those are grafted. And this is a general protocol, grafting protocol. Selection of sign and rootstock means graft combination. Sign and rootstock once need to be selected, and then and based on the compatibility, and then they are sown. The seeds are both the sign and rootstocks are sown separately, and then grafting is done, healing, acclimatization, and transplanting. This is these are the things required. We need a grafting clips, different clips for different crops, and then these are we need, of course, some sanitizers, and then blade, like this thing. And this is one simple. I want to just give you an example of this cucumber grafting. This is the right stage when cucumber is grafted. This is like a 12 days old, 12-13 days old cucumber seedling, and this is a one commercial pumpkin rootstock. This is a Cucurbita maxima mastata hybrid rootstock. Just the true leaf is emerging. This is the right stage. Here it has somewhat expanded or emerged. So this is the right stage, and the grafting is done. And then this is a box grafting technique, hardening technique we are using here, because we are for research purpose. But our entrepreneurs, those are having farm and doing at large scale, they are having the finite pad greenhouse and maintaining temperature, like temperature between 25 to 30 degrees Celsius, and relative humidity at this stage it should not be less than 90% for some few days, 3 to 4 days. Then gradually decreases to 85 to 80%. This is the most important. Splice grafting is the most important one, followed by hole insertion, and tongue approach is a very limited application because of its difficulty to growing two seeds in the same cell. So across globally, actually, this grafting method is the most common. However, hole insertion, China people are using this is very efficiently, particularly for watermelon. One cotyledon grafting, the same. Splice grafting, how it is done, the splice is made this sign, the rootstock, and then apical shoots are removed, and then the scion is cut like this, and then it is attached with the help of grafting clip. And then tongue approach grafting, two seeds are sown in the same cell, whether it's like this bag or a cocoa filled media in pro trays. So this is done like this. And then solanaceous grafting, cleft and tube grafting is is used, and the side grafting or tube grafting is the most commercial one. It is used means commercially, but when there is when we use different rootstocks, then cleft grafting can also be used. Sometimes rootstock girth is higher and the sand is just smaller, than this grafting is can also be used. But the most commercial one, when sand rootstock girth is similar, in case of tomato grafted onto tomato or tomato grafted onto brinjal, this grafting technique is more important. I'm not going into, and robot cobots are also available, but so far they are not in very commercially used, because, and particularly in our country where still we have like a labor availability for doing grafting. But yes, these companies are bringing low cost robot has come up from Indian company. I think that is one that can be used. So this is a comparison using different methods of grafting in different crops by one Italian nursery, 16 Italian nurseries, and they put data, they put together, and they found that the different crops and different grafting methods, the efficiency of the worker is given here. So this is how we are doing here in grafting, graft healing acclimatization chamber. This is one air conditioned room where we have this kind of like optimum condition temperature 25 to 30 degrees Celsius, relative humidity earlier 95%, followed by 85. And that gradually relative humidity increases, and light intensity increases from complete dark to partial light and to full light. And this is the critical period about major grafting vegetables, and for healing 3 to 4 days, for acclimatization 2 to 3 days to 5 to 6 days, and then hardening. These are the requirement for, and the temperature condition, light condition for better output of the grafted seedling. Different graft healing acclimatization systems available across different institutions, different commercial nurseries, like a VNR. They are for particularly for this brinjal, they are using this simply a cloth that is a non-woven fabric and having fogger on the top, and they are creating a microclimate, like a cool, using the cooling pad, and then humidity creating by the use of foggers. But now they are not doing any they are not selling now this grafted seedling. Now they are switched over to supplying the seeds of root stocks and sand. But earlier they used to do that. Then coming to the use application of grafting in the field. So this is one in protected cultivation particularly. This is the major problem in protected cultivation. Soil-borne diseases, whether this is due to Pythium, Phytophthora, Fusarium wilt, bacterial wilt like Ralstonia solanacearum, particularly in the southern part of country where high humidity and then this acidic soil is there. But in northern part of country, it's not a problem. Only Fusarium wilt, Pythium, Phytophthora is a problem. Then to deal with this issue, there are some available options like soil solarization is a must every year during summer, particularly in Polyhouse. And then if there is no time, then soil sterilization can be done within a week using formaldehyde or metal sodium. And farmers, they also tried this kind of system using soil filled in the bags, like in these kind of bags, but it adds investment like a 2.5 to 3 lakhs per acre additional cost for this kind of filling, media, and labor, and so on. So this is not sustainable option, or this is not a very beneficial or economical for the farmers. Of course, this one is, yes, of course, but again, this requires a chemical and time. Like for soil solarization, 2 months time is required. To cope up with this, we tried with this grafting technique, and we found the rootstock grafting cucumber on one cucurbita maximum ostata rootstock. We used several rootstock, but we found that one commercial rootstock from Namdhari seeds, and some bottle gourd rootstock, and also you can use pumpkin, any pumpkin on bottle gourd that will provide this kind of provide resistance to Fusarium wilt. So we found 100% wilt resistance in this case. You can see here multiple at wherever cucumber is planted in 4 replications, and they are wilted, completely wilted. Whereas grafted plants wherever they are not wilted. Means they have resistance, and they provide good yield also. We also tested a farmer's field during summer, and you can see, and farmer got a 50% more yield from the grafted cucumber. And this year also there are few farmers, they are taking grafted cucumber versus normal cucumber. And they now one nursery in Himmatnagar, one nursery in Kolol, they are supplying grafted seedlings to this area. We are expecting very soon one grafted nursery in our area who can supply locally. That is most important actually. Then only grafted plants, the grafted seedlings result could be realized at the ground level, because when it is available everywhere. So grafted brinjal success story, it is coming from the Raipur, Chhattisgarh only, because it's a highlighted. And this crop cycle extended up to 1.5 years, and 180 tons per acre brinjal was harvested, because bacterial wilt is a severe problem, and the standing crop, they are wilted and sudden wilt. And but with the help of this rootstock, they are able to harvest 180 tons per acre within a 1.5 year crop production cycle. Then one student with us published cherry tomato work on to control bacterial wilt, and there was the root stocks. He used local some of the local varieties like Harita, Sopin, Harita from Kerala Agriculture University, Poni, Surya. These are some varieties which are known to be resistant against bacterial wilt. We used and we found success and the like a good production in case of per square meter. If you see from non-grafted 3 to 7 kg, 10 kg per square meter. So this the yield level increased from 3 to 10 kg per square meter with the use of grafted seedlings. So another study was bacterial wilt and nematode complexity in under field condition, and particularly for capsicum. So different root stocks, different genotypes were used as a root stock. Some of the genotypes, they showed a very high resistance, and also they perform well and provide a good yield. And here you can see some of the root stock, they provided like a 6 kg per square meter, whereas the normal non-grafted one like a half kg or less than 1 kg. So because there was a severe wilt and nematode problem, so yield was around 1 kg or half an kg. But in case of some of the root stocks shown like a 5.66 kg per square meter yield of this under experiment of a PhD student. So grafting also increases low temperature stress tolerance. We published in 2019. In this, you see cucumber is a summer season crop. When temperature falls below 15 degrees Celsius, then there is the plants halted. Means the growth is stopped. Only plants standing there but not growing. Even in 1 month period, you could not see even 4 to 5 inch growth. It's like a completely halted growth. So using cold tolerant root stock like a fig leaf gourd, we use bottle gourd, and there the increase in yield was around 38%. And also there was an advancement of production by 15 to 20 days. And you can see the root system. We also extracted the root system of cucumber and the fig leaf gourd and bottle gourd. You can see how vigorous systems are. Root system, they were able to provide nutrient and water. It also grafting also elevate waterlogging stress tolerance. I think Dr. Khapte from Baramati will be presenting in detail. He is doing excellent work. Although the work is started by IHR, and Dr. Bhatt, we published first in 2015 on waterlogging, using some root variety as a root stock and tomato, and provided good tolerance to waterlogging. Then at IAVR, Dr. Anand Badu is also working on this, and then Dr. Khapte is doing complexity of bacterial wilt with waterlogging. That is actually actual practical situation there, and he has selected some of the root stocks. He was earlier posted at Kazri. We worked together for 5 years. Now he has selected some of the good material and using as a root stock for tomato and brinjal both. And then salinity stress, this also provides a good tolerance to salinity. You can see the resistant grafted plants and non-grafted plants, how salinity is affecting. And this is because of the you can see the yield increase control. There is a reduction on the yield, but in case of grafted plants, the yield level was significantly higher. And this was mainly because of the retention of sodium and chloride in the root system. It's not the root stock is not selectively locating nutrient to the shoots, but not the sodium and chloride are. The uptake is of course there, but translocation was restricted by the root stocks. Then this is for normal condition. If we use grafted, and you can see the grafted plants performance as compared to the normal non-grafted plants under field condition, providing all the means optimal supply of the nutrient and water. You can see the grafted plants, they green blue leaf. This is one trait. Now you can see Rizwan company, they have come up, another company also coming with the blue leaf trait in cucumber, that is actually having more photosynthetic efficiency, as well as the tolerance to different diseases, particularly downy mildew, which is most common under during rainy season as well as in cold during winter season. So this trait is this trait can be like generated with the use of rootstock simply. So how grafting and other intervention enhance the productivity of tomato at our place. Earlier, we used to harvest 12 to 14 kg tomatoes per square meter using single stem and 4 months cycle, 5 months cycle. Then we went for two stem, precisely both balanced stem like this, and we increased the yield level from 18 to 20 kg per square meter, and having 2.7 plants per square meter only. Then applying plant lowering, we could extend it 6 meter length of each vine and achieve 100% increase over the first one, 28 to 30 kg. Then using plant lowering, grafting, and this mulching, then further the yield level gone to 35 kg per square meter. In some treatment we could get 40 kg per square meter, means 400 tons per hectare. And this one under low cost net house only. This particular picture, these two pictures coming from there. So of course this was not done in one experiment. This was done in it took a few years from the learning we got from the experimenting different crop in different seasons, different varieties, and the root stock. So finally we achieved this level that we could harvest 35 up to 35 kg per square meter using this technique. So you can also see Kajri ne duguna kiya production. This was published, covered by the. You can see even IRI variety. This one, this is a Pusa golden cherry tomato. You can see the vine length and productivity and production. We could harvest 8 to 10 kg per plant. Where is the breeder himself saying 3.5 to 4 kg per plant is the yield potential, but we could harvest up to 10 kg per plant. A single cluster we harvested 1.2 kg. 1.2 to 1.4 kg from single cluster, and we are having 15 cluster around for over 4 to 5 meters vine length. So every foot one cluster is there. So this is possible with the good management practice, balanced nutrition, irrigation, and also the good agronomic practices. I don't want to discourage, demoralize. Last year I was in conference in abroad. If you know vegetable scientist Leo Marcellus from Netherlands, he is the most renowned scientist, physiologist in horticulture or in vegetable science, and he leads the crop physiology and greenhouse cultivation this team at Wageningen. He showed 50 or 60 years journey of Netherlands greenhouse cultivation. He showed that the contribution of variety, contribution of environment, agronomy, nutrition, everything. To our surprise, there was the highest contribution was the management, particularly this fine tuning with the light and the nutrition and all. That was greatest contribution was there. You give a variety. Even its potential is known potential is this much. If you do good management practice, that's good, because the potential was tested in some condition. That was
Excuse
not
me, sir.
okay.
Due to time limitations, we request you to kindly conclude so
Okay.
that we may proceed to the next part.
So this is how the double stem then taking its a few meter vine length, and they are harvesting 700 tons. I already shown this picture to you. And finally, designer plants production. This grafting, IAVR, Brimato, and Pomato. You can graft tomato on potato. You can graft. You can play with this. You can graft cherry tomato, and yellow tomato, red tomato, black tomato on a single plant. That can be possible only by grafting. And this is some of the pictures of from our greenhouses. This is another one. What I have shown you. This one. This is another experiment. 1 year experiment. Another earlier was this one, the single without lowering. So you can see the advantage of lowering itself and producing more food. And these are the hydroponic systems with different greenhouses with the agriculture minister. And you can see the colored capsicum and tomato in this kind of harvesting. We are taking 12 to 15 kg. And we also introduced 2 years, 3 years, rather I say 3 seasons, third year. This seedless brinjal in for greenhouse. It's like a 10 feet height. We are taking and we are harvesting 8 to 10 kg per plant, retaining 2 stem per plant, and this weigh around 400 to 500 grams seedless brinjal, and it is sold at premium price. Then capsicum, then again these are the similar to it. So to conclude, protected cultivation, this increases productivity, profitability, and sustainability. Smart fertilization is very essential when it comes to achieve higher yield or sustainability. Soilless cultivation for urban area for healthy and secure production to increase water use and nutrient efficiency. Vegetable grafting, increasing biotic and biotic state, water use efficiency. Integrated approach using solar, rainwater, harvested, protected cultivation. And focus should be given for region is wise, not region wise. Design, system, crop is specific, everything means all design, systems, crop, and specific plans for each crop. Manage favorable aerial and root zone environment is important. Skill development for farmers and extension staff, because this is most important part. Unless we train farmers or extension staff, this is not going to yield what we expect. Hand holding is the very key area in protected cultivation, because it's a new, it's not a regular farming. That is most important. You have everything, you have a all thing available there, but if you don't have, then it's not going to lead a success. So future undertaking, IoT application can be enhanced and up to optimize the environment, root zone, whether it's a fertigation, everything. Breeding, designer crop. Designer crop is requirement. There are only few crops. We need to increase the basket of the crops and varieties, particularly crops. Then resistant root stocks also. Customized protected structure, design, and good agronomy practices for the greenhouse cultivation. Develop entrepreneurial ecosystem in protected cultivation. This is most important. Thank you. I think I am done. Okay. Thank you.
As time is already over, so we will take few questions. Kindly ask questions.
Okay.